Hello everyone. Okay, so in this video we are learning about chain rule, differentiating by chain rule. So what is chain rule and when do we use it? So the chain rule is used when we have a composite function, right? So remember, composite functions are like functions within a function. So this involves differentiating a function of another function, often with powers and roots. So what do I mean by that? We're going to be now looking at differentiating functions like this. Say f of x is equal to 3x plus 2 squared, right? It might look like it, but this is actually a composite function, right? My inner function is 3x plus 2, but my outer function is just squaring it. So we're looking for dy dx. I have two functions here, and what we basically do is we call your inner function here u. You find the derivative of the kind of inner function. Then so I find the derivative of the outer function. I find the derivative then of the inner function with respect to x. And if you treat these kind of like fractions, you know, I have dy over du times du over dx. Well, them du's are going to cancel out. And then I'm left with a dy dx. So what do I mean here? Right? So I call my kind of inner function u. So I'm left with f of x is equal to u to the power of 2. So first I find dy du. That is going to be 2u. Then I find du dx, right? Well, u is equal to 3x plus 2. So 3x plus 2, well, that is going to be equal to 3. And then what I simply do is I multiply these together. So my dy dx is going to be equal to 2u times 3, which is 6u. Sub u back in, I get 6 times 3x plus 2. Right? And that is kind of what chain rule is at its as it is, right? So you kind of relabel your inner function as u, you find the derivative of y with respect to your inner function u, and then you find the derivative of your inner function with respect to x. This is the formal, proper way of using chain rule. The fast way, and the way that I will probably be using now for the rest of the video, is what you do is you rewrite the function as a power, you differentiate the outer power, you then differentiate the inner function, then multiply the derivatives together and simplify the results. So what do I mean here? Let's look here, 4x squared plus 1, right? The fast way, this would be 4x squared plus 1, the power of a half. Next, differentiate the outer power. I'm going to have a half times 4x squared plus 1. A half minus 1 is minus a half. Then differentiate the inner function. The inner function, well, that'll just differentiate to 8x, so 4x squared plus 1. So differentiate what's in the bracket. That's what I mean by inner function, like what's in the bracket. That'll be 8x, then you multiply them together. So a half of this times 8x will be, well, half times 8x is 4x. That'll be 4x times 4x squared plus 1 times minus a half. And then so my result is 4x over 4x squared plus 1, square root all that. So that's the fast way, right? So differentiate the power, then multiply by the derivative inside the bracket. So let's just look at the formal way one more time. So the formal way one more time is, so we're going to still do this one, y is equal to root 4x plus 1. So rewrite the function in a differentiable form. So rewrite the original function using exponents. So rewrite it as the power of a half. Then rewrite it as your inner and your outer function. So u is going to be 4x squared plus 1. And then my outer function here is going to be u to the power of a half. Differentiate the inner function with respect to x. So find du dx. That is going to be 8x. Then differentiate, you know, this dy du here. That is going to give me a half u to the power of minus a half. Then I multiply them together. Multiply them together. Then substitute 4x squared plus 1 back in. So multiply them together out now. So wherever you put in 4x squared plus 1, multiply it in, simplify the results. I'm going to get what I got here on the left-hand side. So chain rule is it's handy for when we're doing our related rates of change in our next chapter, right? Let's look at some examples here. The function f is defined as 1 over 15x squared plus 7. F of x is the derivative of f defined in simplest form. So I can rewrite this. You could use quotient rule, but one of these chain rule. I can rewrite this as 15x squared plus 7 to the power of minus 1. So differentiate the power, it'd be minus 1, then times 15x squared plus 7, minus 1 is minus 2. Multiply by the derivative of my bracket, and the derivative of my bracket is 30x. And this will be equal to 30x times minus 1 is minus 30x. And then 15x squared plus 7 to the power of minus 2 will just be 15x squared plus 7 squared all over that. Alright, so this is, I find, for me, I find this a bit more straightforward and easier way of doing it. Right, what about here? 4x squared minus 1 cubed. So I know I have to use chain rule because I see a power. So when we see power or roots, that's when we have to use chain rule. So bring it down, be 3 times 4x squared minus 1, reduce the power by 1, then multiply by the derivative of the bracket, which is equal to 8x. This is going to be 24x times 4x squared minus 1 squared. Right? Next one here, 1 plus 7x cubed. That is going to be 3 times 1 plus 7x squared. Then multiply by the derivative of the bracket, which is equal to 7. So I'm left with 21 times 1 plus 7x squared. That is chain rule. So sometimes we could be asked to use chain rule within, we could ask to use chain rule within a product or quotient rule. Let's look at this one here. Y is equal to x times 1 plus 3x squared cubed. Well, u, using my product rule, u is equal to x. V is equal to 1 plus 3x squared cubed. Du dx is equal to 1. dv dx, I'm going to have to use my product, my, what's it called, chain rule here. So it would be 3, bring the power down, 3 times 1 plus 3x squared, then multiply by the derivative of the bracket, and the derivative of the bracket is 6x. Therefore, this will be equal to 3 times 6x, which is 18x, 1 plus 3x squared. So, product rule, u times dv dx is going to be 18x squared times 1 plus 3x squared minus v times du dx would be minus 1 plus 3x squared cubed. And your answer is perfectly a-okay like this. I'm just noticing, I could factor out 1 plus 3x squared. So I could factor out this term from both sides. And I'm left with 1 plus 3x squared, and I'm left with 18x squared. Minus 1 plus 3x squared. I'm left with 1 plus 3x squared. 1 plus 3x squared times 21x squared minus 1. There you go. Do it like that. Don't have to, but that is there. This one here. So y is equal to root 2x plus 1. So I'm going to be using chain rule of the top part here. So u is equal to root 2x, which is equal to 2x plus 1 of a half. So du dx is going to be equal to a half times 2x plus 1 to the power of minus a half, because a half minus 1 is minus a half, multiplied by the derivative of my bracket. The derivative of my bracket is 2. So them 2 is going to cancel out here. So this is actually going to be equal to 1 over root 2x. So I have u, I have du. What's v? So v is going to be equal to x plus 3. dv dx is going to be equal to 1. So u times dv dx, oh, so it's quotient rule. So it's v times du dx, so be x plus 3 times 1 over 2x plus 1. So that'll just be x plus 3 all over root 2x 1 minus u dv. That'll be minus root 2x plus 1. So that's going to be all over 1. I'll tell you why now, support in a second. All over x plus 3 squared. So I'm adding two fractions here, so I need to multiply the top and the bottom here by root 2x plus 1. The lowest common denominator. So I'm left with now x plus 3 minus root 2x plus 1 times root 2x plus 1 is just 2x plus 1 all over root 2x plus 1 all over x plus 3 squared. This is going to be equal to minus x plus 2 all over. So I'm basically essentially dividing this fraction here by this. So if I'm dividing a fraction, I just multiply the denominators. That's going to be root 2x plus 1 times x plus 3 squared. That one was a tricky one. That one was a tricky one. Right. And then here, this one's 974. So differentiate with respect to x. So this can be written as x over x plus 1 to the power of a half. We're going to use chain rule. That's going to be a half times x over x plus 1. A half minus 1 is minus a half. Then multiplied by the derivative of my bracket. Now the derivative of my bracket is going to be quotient rule. So u is equal to x, v is equal to x plus 1. du dx is equal to 1. dv dx is also equal to 1. So it's going to be x plus 1 minus x times 1 all over x plus 1 squared, which is equal to 1 over x plus 1 squared. So multiply by 1 over x plus 1 squared, derivative of my inner bracket. I'm going to be left with here now 1 over 2 multiplied by a half, so it's reciprocal, flip this, root x plus 1 all over root x times 1 over x plus 1 squared. And then, oh sure, look, this is just going to be equal to root x minus x plus 1 all over 2 root x times x plus 1 squared. Like, that one was a bit messy there, but that's how we do that one there. And sure, look, that's chain rule. This video was some help, guys. Not my best work today, but sure, look, if you found this video helpful, I'll catch you guys later. Bye.